Welcome. This question says a 2 kilogram block sits on a level table. There's a 0.4 coefficient of static friction between the block and the table. What is the maximum force of friction that can be produced by the system? So let's picture the system. So here's my block and here's my table. And it's a 2 kilogram block, so I like to put the numerical value of the mass in kilograms inside the block. And I know because it's on the surface of the Earth and the gravitational field strength is 10 newtons per kilogram, this is going to be 20 newtons pointing downwards. And I also know that there's going to be a normal force that is pointing perpendicular to the surface. And if I have an applied force, let's put the applied force to the side. If I am not beginning to move, that is, if I am have a constant velocity of 0, then I am in equilibrium because I'm not accelerating. So I must have an equal and opposite frictional force. So there's my visualization of my system. And the question says, what is the maximum force of friction that can be produced by the system? So let's remind ourselves of the pertinent equation, and it is that FF is less than or equal to mu static times Fn. And that's where this less than or equal to comes in. Let's look at this. If I plot a graph of FF versus the force applied, what I would see is that for the beginning part, my force applied will be matched by a frictional force. If it's a 1 Newton force applied, it's a 1 Newton frictional force. If it's a 2 Newton force applied, it's a 2 Newton frictional force. It matches because the object is still stationary, and so it is not accelerating, and so it hasn't started moving. But there comes a point when you start moving, and what happens is then, as you increase the applied force, the frictional force becomes constant, and it's actually constant at a value which is less than this maximum value. This is the maximum value of the friction force. That's the maximum value of the friction force. And so under these circumstances, we'd say, well, at the point of slipping, FF is actually equal to mu s times Fn. This is at max. Okay, so I'm talking about this point where I'm just about to slip, and that's the maximum value of friction I can get out of the system. What is that maximum value? Well, if we substitute our values in, FF max is equal to, well, 0.4, because that's the coefficient of friction, times Fn. Oh, okay. I don't actually know what Fn is. It's on my diagram, but I need to find it. Some people are very comfortable at this point looking at the diagram and just stating the value of Fn. And when you're on a horizontal surface, that is pretty straightforward. But when you're on a sloping surface, that becomes less and less straightforward. So let's just try to formally find this value. And I'll say, well, let's find FF using the sum of the forces equals 0. And we can say that because we're in equilibrium. Now, I've got to decide on my axis. And if I look at this, I don't want to deal with I'm sorry. I don't want to, I'm sorry, I need to correct that. I want to find Fn. So if I look at this, I don't want to deal with FA and I don't want to deal with FF. I only want to deal with FN. What I find is if I choose my axis perpendicular to the forces that I don't want to deal with, they have no component in that direction. So I'll say vertical, because if I pick a vertical axis, then FF is not involved and FA is not involved. And so I say, oh, let's call this the positive end, let's call this the negative end. And I say plus Fn, because it's pointing upwards, added to minus 20, because it's pointing downwards, equals 0. So Fn is equal to 20 newtons. It's pretty trivial when you're horizontal, but when you, as I say, when you're at a slope, you know, you might have to work a little bit harder to get it. So we can now bring this over here. And we say FF max is equal to 0.4 times 20. FF max is equal to 2 4s are 8 newtons. Put that in a nice box so we can find it easily. We look on the answer key and there's the answer. It's there. So let's review. As usual, we visualized and we made sure that we had all of the forces on our system. And then we selected the relationship that we wanted. We thought about it because it asked for the maximum value. So we tried to determine when do we use the less than and when do we use the equal to. And then we substituted in what we knew. And we knew that μs equals 0.4. We recognize we need to find Fn. And so we reanalyzed our diagram to find Fn using Newton's first law. We picked a good axis so that we did not need to worry about unknowns. We numerically found the value of Fn, and then we substituted back into our equation. So step by step we can work our way through it, and there we have it.